No, they just have a mental problem. Giovanni Perez, what did you get for your y values here? Okay, now if we were to graph this as part B is asking us to do, and this should look really repetitive to you guys. If it doesn't look repetitive, you didn't do your homework. Because these were homework questions. I'm just giving it to you again. So we have 0, 0, 1, 1, 4, 2, and 9, 3. So this graph would look something like that.
Yes, I got it.
Okay? That's what square root functions look like. They look like half of a sideways parabola. Okay? Let's take a look at the next one here. Alex, what'd you get for this column over here? Okay. That's enough, Dylan. Thank you. Okay. Dylan. All right. So I'm gonna kind of fudge this one. This is 1. We're gonna put 8 like here. We're gonna put 27 way over here because I don't want to draw that many little lines.
I think you do, Bailey.
All right. So negative 27 and negative 3 would be like here-ish. Negative 8, negative 2 would be here, then 0, and so on.
No. Bailey, I think you want to be replaced.
It would have a slight bend to it.
It looks like it wants to be the beloved Bailey.
Yes.
Yeah, we got it right.
I think Mr. Bailey thinks you're very strange.
No, I don't.
I think strangely, so it's okay.
I don't think he's strange, actually.
Really, I think I'm
Yes. Well, guys, today we're graphing square root functions and we're graphing cube root functions. Every time we look at a new function, we learn how to graph it. So today we're graphing those guys. Now, just so you guys know, anytime you have an even function, it has this shape. And anytime you have an odd rooted function, it has this shape. I don't think you need to copy it because you have your warm-up with the graphs on there. That's good enough. If you didn't get the graph, you might want to sketch something real quick, but I'm not going to stay here much longer. But it doesn't matter what root it is. If it's a second root or a fourth root, sixth root, any even root will have a shape roughly like this. And even any odd root will have a shape roughly like this. It does get a little bit more stretched or compressed depending on what that power is. But for our class, all we're going to be graphing, and all you ever really need to do is square roots and cube roots. I've just never seen any classes do anything other than that. So that's all we're really going to worry about. So you don't need to write this, but I just want to...
Gosh darn it, Bailey. Go back to the previous slide.
This is what you get for not doing the warm-up.
I'll help you out in a minute. So I just want to refresh your memory on some transformations. When you add a number to your function, what happens? Translates up. And when you subtract, down. What about when you add or subtract a number on the inside?
But it's the opposite of it.
Yeah, so this would be left and this would be right. This would be flipping it upside down, right? Flip upside down. What would this do?
I've never seen that one. Or at least not in that context.
It flips downside down.
Flip sideways, horizontal flip.
Maybe I have.
We called them reflections before. Quiet, please, guys. So, when you multiply your function by an a on the outside, it either stretches it or compresses it vertically, depending on whether a is a bigger number or a smaller number. And when you multiply a on the inside, it compresses and stretches it horizontally. But, like I said, I'm not going to, the ones we really need to focus on today are these two. I'm not really going to give much attention to these today. we're going to need to remember these basically to graph. But like I said, you don't need to write the slide because we're going to write what these things do on the other slide. So go ahead and write down this slide, please. I said not to write that one down. But here we go. So I don't want you guys to write this. Just pay attention for now. We're going to add. We will be writing something in a minute, though. But in the beginning of class, you guys graphed this thing, right?
Sure. Yeah.
And what that looked like is it looked like this. So if I were to take this function and subtract a number from it on the inside and add a number to it on the outside, what that's going to do is it's going to shift the whole graph to the right and up, right? So, you know, it might look like this now.
That's some more depression.
And so here's what I want you guys to know. At the beginning, this point is 0, 0. But after you shift it, those will be your new starting point. So H and K, what they tell you is they tell you the starting point. And this is what I would like you guys to, well, actually, you don't need to write that either. This is where I'd like you to start writing with me. We'll call this HK right here. Draw that shape.
Why does everyone want us to draw?
Now,
Can't draw. It's so mean. It's so unfortunate.
what does what mean? The H and K is from these two numbers here. And I'll show you how that applies in a problem in a minute. But basically, whatever numbers are here, we're going to call that our starting point. Okay? Now, remember, if you have a negative on the outside, and that flips it upside down. If you have a negative on the inside, it flips it sideways.
Oh, that's fun.
So, in this case, that was just the regular square root of x. So that's what your graph would look like if you had a positive a and a positive b. But what if we had a negative a? Well, it would get flipped upside down, so it would look like that. What if your a was positive, but the b was negative? It's going to flip it sideways. So if you have a negative b but a positive a, it'll look like this. And if they're both negative, then it gets flipped sideways, and then it gets flipped upside down. And so what I've done here is I've created a little chart for you guys where based on the sign of the A and the B, you should be able to determine the shape of the graph. So this is positive A, positive B. This is positive A, negative B, etc. So the way we're going to be graphing these is we're going to start with our starting point, which is HK, and then from there, we're going to be using that little chart to figure out what the rest of our thing would look like. All right?
The bottom right one?
What about it?
Negative A, negative B?
Yeah. Negative B and negative A. Okay. Now, anytime your B is positive, look at your arrow. The arrow points to the right. And when your B is negative, your arrow points to the left. So if you have a negative inside the radical in front of the x, your graph is pointing to the left. If you have a positive in there, it's pointing to the right. For the A's, a positive A means that the graph is going up, whereas a negative A means it's going down. Okay? All right, so there's our summary of the different types of shapes. So we're just going to graph a couple of these. Go ahead and write down example 1, directions there, and then number 1. So, first thing we want to do is we want to find our starting point. Notice this graph has a +4 here and a +5. When you add 4, that means it's being shifted to the left 4. Adding 5 means it gets shifted up 5. So my vertex, or not, it's not a vertex, I shouldn't call it that, we'll call it a starting point, is going to be -4, 5. Remember how you change the sign of the one that's inside the brackets there or whatever? So my starting point is -4, +5. Now, I don't have my A and B written down here, but B is the number in front of X and A is the number in front of the radical, and they're both just 1. So that means they're both positive. So I'm going to take the time, although you don't have to do this on your homework or anything, but for notes it's nice. I'm going to take the time to identify the fact that those are both positive. And then I'm going to use my chart. So if you guys look at your chart, find the quadrant where both A and B are positive. So since A is positive, it's one of the ones that's going up. And since B is positive, it's the one that's going up and right. So it looks like this. So this is going to be my starting point, and my shape is going that way. So let's go ahead and put it on a graph, and we can say that we've officially accomplished the task. So I'm going to go to the point -4, 5. And there's that. And then I know that's my shape. So from there, I'm just going to go like this, and I'm good. So that's the basic idea of how to graph a square root function. Now you could get more specific. You know, if instead of just fudging this line and guessing where it would be, you can get more specific and plug in numbers like 2, or sorry, -3, -2, -1, maybe even 0 to find your y-intercept. You can get a few more dots to get more specific, but I think for the purpose of our class, starting point and direction is pretty much good enough so long as you know the shape. All right, let's go ahead and do a second problem. We're going to do a couple of these. Oh, thank you for reminding me. We should do the domain and range. We should do the domain. So let's do that.
Oh no, I've said this once and I've said this twice. You were going to be the bane of my existence. I'm sorry.
All right. Domain, in case you guys forgot, is all the possible values of x. Range is all the possible values of y. All right. So, what's the farthest point to the left? What's the x value of the farthest point to the left? To the left is -4, right here.
Infinity.
But to the right is infinity. Now, how about the range? What's the lowest point? 5, and the highest y value is? It would just keep going up forever, slowly, very slowly, but it would keep going up forever. All right, so that's the domain and range. I probably we'll do it one more time, but I don't think we do it every time, but there you have it. All right, let's go ahead and write down number 2 if you haven't done so already. I just wanted you to copy it. Did you not copy the equation yet?
Bailey, I'm almost done.
Oh, well, good. This is an example, though, so I do these. But if you want to be an overachiever, I appreciate that. Okay, first things first. What am I missing here? We have our what is our A value? What's our B value? What's our H value? And what about our K value? Good. So you might want to be aware of all those missing numbers. That's kind of helpful. Thanks, Kaylin. Good job. Now, here's the next thing that I want you guys to be. You guys remember what happens when you have a number here and here?
Just sleep. I'm gonna throw this forward.
When you have a number here and here, you're going to have to factor that front number out. So it's going to look like this. You guys remember that?
But we didn't do that enough.
We've done it on a few problems, but didn't have it. We had a 1. Now, if you factor a 1 out, nothing changes. So we just leave it. But if you have anything other than a 1, you're going to want to do that.
Bailey, stop making us do math.
Okay. Yes. Sure. Now, if I divide a -1 out of here, what will be left in the parentheses?
X.
-2. Notice how that changes the sign, which means that's going to affect what your H value turns out to be. All right. So, what is my starting point? 2, 0. Remember, you change the sign of this number when you write it as a point. That goes there. Now, notice that my A is positive and my B is negative.
It's going to the
It's going
left.
left and So it's going to look like this, where that's my starting point. So I'm going to start at 2, 0, and it's going like that.
Bailey, I don't appreciate this.
You do.
No.
You like it.
I appreciate it. No, I don't appreciate it because you're making me redo my domain and range again. How dare you?
Speaking of domain and range, let's do that. Okay. What is the point farthest to the left? Negative infinity. What's the point farthest to the right? Well, for the x value, it's 2. Now, what's the point that is lowest on the graph for the y value? 0, and the highest is infinity again. So there's your domain and range. Can't help it. It's a natural inclination. Okay. So don't forget, if you have a number in the front here, you got to factor it out of the pair. All right, let's do number 3. Let's do number 3.
Bailey, stop making me do my bad boy.
Okay, so here we go. I'm going to use my cards this time, let you guys walk me through some of this stuff. Andy, what's my starting point on this problem?
It's absolute. The starting point is
okay, we don't have an h inside the bracket with the x, so that would be 0, and my k is 5. Good. That's my starting point. And then I'm going to give you guys a second to think before I call on you. I'm going to ask you, what direction is this going? Up and right, up and left, down and right, down and left. Which of those 4 options is it? So go ahead and think for a moment. Good. So the A is negative, the B is positive, that's down and right. So if we wanted to graph it then, we would start at 0, 5, and we would go down and right. And there's my graph. And once again, we should probably do our domain and range. But I don't know. I think we're good. I don't know. We better do it.
I think we should do it.
We better
I
do it.
think we should do it too.
We better do
considering
it.
I just did it.
What is the farthest x value to the left? 0. What is the farthest x value to the right? What is the lowest y value? Infinity, good, negative infinity. And what's the highest y value? There we go. All right, I think there might be one more.
No. Bailey, no.
That's enough.
Oh, yes. Write it down. What do you guys notice that's weird about number 4?
There's a 4
Get the X factor.
in the B spot.
That's true, but that's not what's weird, really.
There's a 4 in the B spot.
There's a 4 in the B spot, kind of. No, that's normal.
That's not weird. It's the negative X is after the 4.
Okay, so what's weird is it's supposed to be x and then minus a number. It's not supposed to be a number and then minus the x. So what we're going to do first is we're going to switch this around. So I'm going to put the negative x in the front. And now, like Josh was saying, now, yes, we do need to factor out the -1. So it's going to be -1 x minus 4. Now, what is my starting point?
We got it.
4, 1. And notice how they're both negative. Which way is this thing going? Down and left. All right, so let's graph it.
Wait, what?
Whoa. Holy smokes, what happened?
That's down and right.
Did I go the wrong direction?
Yeah.
Ridiculous. Down and left is right. Good job. Wait, down and left is right?
Yeah.
What's
I
happening?
said that and you said yeah, and then you put the wrong thing down.
Down and
Really?
down and left is left.
He's not paying attention to me. He's not getting my answer.
Well, you factored out at
Bailey, stop making me want to.
I think I'll skip the domain and range on this one, but
Thank God.
Good, I didn't do it. So that's okay.
all right, I'm gonna
Wait,
let you guys do some studiante practice here.
Oh my gosh.
Some practice por los estudiantes.
can you just not, Bailey?
I could just not, but I'm going to just.
Ah!
And then you have guided practices too. Oh my gosh.
My advice would be at least do it mentally. So when I call on you, you have an answer for me.
Yes,
So
I can do
here
it.
is your student practice. I shall give you a moment to try those. All right, guys. So for number 1, check your answer. We should have our starting point be at -1, -2. So left 1, down 2. Notice that your A and B are both positive, so it should be going in that direction. Okay, next one. Oh, Alan, I just realized this. I think I might have misled a few of you guys. It looked to me like when I was out there, a lot of you guys wrote this one like this. That's one thing. But what's up here is another. Okay? In this case, a lot of people, I think I was telling them to factor the -1 out. But you don't because that 3 is not under the root with the x. So for this one, let me ask Ricardo, what is our starting point on number 2, Ricardo? Good. And as for the direction, Robert, what direction does this one go in? Yeah, up, is it up and right, up and left, down and right, down and left? It's down and left. So this one tells us it goes down, this one tells us it goes left. So it looks like this basically. And so if we start at 0, 3, which would be here, we would have that answer. That was the point of it, yeah. All right, next one. Jermaine, what do we have to do first on this one? 3.
First thing we do is let it factor out.
That's right. Now check this one out, you guys. I think quite a few of you probably got this one wrong. So make sure you check. -2, you're going to factor that out. If you factor that out, what's on the inside? X minus 1. Because you're dividing by a -2, right? So if you divide this by -2, you get x. If you divide this by -2, you get -1. All right? And my missing k value is 0. So, Cece, what's my starting point on this problem?
It's 1 and 2.
Good. And what directions is this going, Gene? Close. It's up because it's a positive A, but it's left because of the 2. So it's going to be looking like that. So 2, 1, 0 is here. Up and left would look like that. And there's our graph. Okay. So Diana, I think you were another person who I led astray. Did you have this thing going all the way over like that? Okay, that's why. If it's not there, then you don't factor out the negative. Yeah. You got the correction though? Yeah. Okay. Yep. Okay. Let's we're going to talk about cube functions now. Cube root functions. So go ahead and write this down. Really?
Yeah. Oh yeah, I was so right.
I mean, you can cut it off and we can cut it tomorrow. Exactly. They make a bunch of
It's Monday.
And the bells are really off currently.
Yes, they don't know what
They fixed that first period bell.
Bro, I won't see my first bell.
Guys, they fixed the bell schedule in second.
That's great.
Okay, here we go. Now, on our warm-up this morning, you guys, we graphed this thing, and our shape looked like this.
A swivelly S.
Now, in this case, we have a starting point again. Our starting point is right here, though. Okay? So the H and K is there. So I'm going to give you another chart, once again, based on whether the A is positive or negative, and whether the B is positive or negative. Okay, so when they're both positive, it looks like what we graphed this morning, or I'm sorry, at the beginning of class today, and your starting point HK is right there in the middle. If your A is negative, that flips the graph upside down and it looks like this. If your A is positive, but the B is negative, it flips it sideways and it looks like this. What do you guys notice about this box and this box?
They're the exact same.
They really are the exact same. So whether you have a positive A or a negative B, I'm sorry, negative A or negative B, they really do the same thing to the graph. So what do you think would happen if I made them both negative?
It would like flip.
They look the same like the first one.
It'll look the same as the original because it's like two negatives canceling each other out. That didn't happen with the last one because negative A and negative B did different things. But on this one, they actually do the same thing. So there's your 4 possibilities. I think that we could probably suffice to do just one example and one student practice with this because that's the only difference is being aware of the fact that, oh, okay, so this is a cube root, so this is the shape I'm going for instead of the square root shape.
Back up. You have 5 minutes.
Well, it's your guys' grade. I'm going to teach it, and whether you want to learn it so that you can do your homework and pass the test, it's up to you. But don't distract others while you choose to
So Talia
not work. All right. So
said to distract others. She said don't distract others.
here we go. I think we will do number 1. So write down number 1.
Haley.
Yeah.
All right. I didn't finish it.
Well, Dylan, you're texting.
I wasn't even texting. I was putting speak ups.
Okay. So pretty much the same thing as square root. So you want to start with your starting point here. What is the starting point?
5.
5, 1. Notice that I've got a positive B and a positive A.
But it's always
So it's going the right way.
What? Why would we?
So there's my starting point. And since they're both positive, it has this shape.
The squiggly S.
Okay? Now, just so you guys know, this graph always goes to the left and right, and it always goes up and down. So for the domain and range,
Negative infinity and then infinity.
they're both infinity. I'll just write it like that. Just parentheses, negative infinity, positive infinity. Okay? We are a little bit low on time, but if you'd like to try graphing one, I would suggest trying number 3. And I'll put the answer up in about a minute or so. But that would close us out for the day. So that's what it should look like, you guys, if you did it.
all it cost was not